Okay guys, I'm going to answer question 8 from the homework that I assigned to you. So let's read the question first. Question 8, the diagram shows 3 touching circles with radii 6 cm, 4 cm and 2 cm. Find the area of the shaded region. So we have 3 circles here and we have radius lines, right, connecting the centers of all the circles going through points of tangency. So this makes a triangle here, if you realize. And so since we don't know how to find directly the area of this shaded region, we need to find the area of this triangle, and then we subtract the area of each of these sectors. Okay, we subtract the area of each of these sectors from the area of this triangle, and we will get the area of the shaded regions. Okay, so let's look at the lengths of the sides of the triangle, and we can see on this side the length is 6, this length here is 8, and this length here is 10. So that's a 6, 8, 10 triangle, which is a Pythagorean triple. 6, 8, 10 is a Pythagorean triple. That means that this is a right triangle. So we can say, hey, that's right angled. So since this is a right triangle, then the area of right triangle, I'll just use this, right, is equal to half times 6 times 8. And this will give us 24 units squared. Okay, now we need to find the area of each of the sectors. Now the easiest one would be this small sector here. Area of the small sector, because it's a quarter circle because of the right angle triangle there. So that would be 1 over 4 times the area of the whole circle. So 1 over 4 pi r squared, 2 squared, right? The 2 squared is 4, 4 and 4 will cancel out, and we get pi units squared. All right, let's look at this now. So the remaining 2 triangles, we don't know the actual angles there. So what we're going to do is we're going to call each of them differently. We'll call this alpha and we'll call this theta. So we're just going to use some trigo. We don't really need to find what are the actual angles of alpha and theta, because we're going to use trigo and we'll just express it in terms of those trigos, right? So for example, for this alpha here, we know that cosine alpha is 6 over 10, which is 0.6. Therefore, alpha is cosine inverse or inverse cosine of 0.6. And cosine theta is 8 over 10, which is 0.8. So theta is inverse cosine 0.8. And we're going to use these for the values of these angles, okay, in radian, of course. Make sure you use radian mode on your calculator. Let's go ahead and calculate the area of this sector, right? This sector with alpha. The alpha, let's call it the alpha sector. Area of alpha sector, right, I'll draw it like that, okay, right? That will be equal to half r squared theta, or in this case half r squared alpha. So half, and now r here is 4, so 4 squared, and alpha is cosine inverse 0.6. And so 4 squared 16 divided by 2 is 8, so it's 8 cosine inverse 0.6. And then area of the biggest sector there, let's call it that sector, sector theta, that's half r squared, this one is 6 squared cosine inverse 0.8. Okay, and that would be 6 squared 36 divided by 2, that's 18. 18 cosine inverse 0.8. So now for the area of shaded region, area of shaded region will be area of the triangle minus the 3 sectors. So area of triangle is 24, minus the sectors will be minus pi, and then minus 8 cosine inverse 0.6, and then minus 18 cosine inverse 0.8. So we're going to calculate that using our calculator. make sure it's in radian mode, and we get something to the tune of 1.857 units squared. And for A levels, you can actually round this to three significant figures, which is approximately 1.86 units squared, and that'll be the answer for the area of this shaded region. Okay, so hopefully that was helpful, and I'll see you in class.